Section 4.2, Introducing Permutations and Factorial Notation. A permutation is an arrangement of distinguishable objects in a definite order. For example, the objects A and B have two definite permutations. You can arrange them as AB, and you can also arrange them as BA. Example, Naomi volunteers after school at a daycare in Whitehorse. Each afternoon she lines up her group of students at the fountain for a drink of water. How many different arrangements of children can Naomi create if there are 6 children in her age group? There are 6 positions, A, B, C, and D, E, F. There are 6 possible children that can stand at position A, leaving 5 left for position B, which then leaves 4 left for position C, and 3 left for position D, and so on. So we can let L represent the total number of permutations. L is equal to 6 times 5 times 4 times 3 times 2 times 1. Written in factorial notation, this would be 6 factorial. It said product 6 factorial. You can plug the factorial into your calculator using that fancy exclamation point button, or you can plug it in longhand, which works out to 720. So there are 720 permutations of the 6 children at the fountain. Here's an example involving more factorial notation. So to evaluate 10 factorial, you can plug it into your calculator to get the answer, or you can do it longhand. 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Either way, you'll get the same answer. B, now we're dealing with more than one operation. So we have 12 factorial divided by 9 factorial times 3 factorial. Here they've written it out longhand. So if you write it out longhand, you can simplify the expression by aligning the common factors in the numerator and denominator. So this is what she did. She aligned the common factors. So we have 9 over 9, 8 over 8, 7 over 7, etc. Then she realized, oh hey, but this is actually 9 factorial. So we can actually write this as 9 factorial. Then she simplified again by dividing 12 by 6. The product of the denominators 2 and 3. Then, using mental math, she evaluated to get her final answer. We can also simplify algebraic expressions. So we have n plus 3 times n plus 2 factorial. N plus 2 factorial will work out to n plus 2 times n plus 1 times n minus 1 all the way down until we get to just 1. So n plus 3 times n plus 2 is equal to n plus 3 times n plus 2 times n plus 1 times n minus 1 times 3 times 2 times 1. But she knows that 5 factorial is equal to 5 times 4 factorial, so it makes sense that n factorial is equal to n times n minus 1 factorial. She used this reasoning to simplify the product, since n plus 3 and the factors n plus 2 factorial are all the factors of n plus 3 factorial. So then she simplified and got n plus 3 factorial. In B, n plus 1 factorial divided by n minus 1 factorial. She wrote out all of her factors, so n plus 1 times n minus 1 times n minus 2 times n minus 3, all the way down to 1. And she did the same for n minus 1. n minus 1, n minus 2, n minus 3, all the way down to 1. Then she looked for common factors in the numerator and the denominator, and she found them. Her common factors start at n minus 1, so all of these can be written as n minus 1 factorial. So n plus 1 factorial divided by n minus 1 factorial is equal to n plus 1 times n minus 1 factorial divided by n minus 1 factorial. But if you look, these can actually cancel out. So n plus 1 factorial divided by n minus 1 factorial is then equal to n plus 1 times n. Then she distributed this in to get n squared plus n. Key ideas. A permutation is an arrangement of objects in definite order, where each object appears only once in each arrangement. For example, the set of 3 objects A, B, and C can be listed in 6 different orders arrangements of permutations given here. The expression n factorial is called n factorial and represents the number of permutations of a set of n different objects and is calculated as n factorial is equal to n times n minus 1 times n minus 2 all the way down to 1. What we need to know. In the expression n factorial, the variable n is defined only for the values that belong to the set of natural numbers. That is, n is within 1 to infinity.